On this video, we're going to go ahead and look at multiplying special case polynomials. And honestly, we look at example 1 here. It is nothing different than what we've been doing. Okay, it is nothing different. If we look at x plus 8 and we see that squared sign, what does squared mean? Times itself. So what I would tell students every single time is let's rewrite this. It's x plus 8 times x plus 8. And we really just have a binomial times a binomial. Let's go ahead and apply the distributive property and make sure we multiply everything in the first set of parentheses to everything in the second. X times x is x squared. X times 8 is 8x. So I multiplied the x by everything. Now let's look at the 8. 8 times x is 8x. And 8 times 8 is 64. Make sure that we combine those like terms. And our final answer here would be x squared plus 16x plus 64. So again, the process is the same. These are special cases. However, we can go through the same multiplying process. Let's look at the next example. I have 2m minus 3 and it says squared. I would rewrite that as 2m. First of all, I'd make it plus negative 3 times itself. That's what squared means. 2m plus negative 3. And so as we go through the multiplying process here, 2m times 2m is just 4m squared. 2m times a negative 3 is going to be a negative 6m. Let's go ahead and now we need to make sure the negative 3 is multiplied by everything. Negative 3 times 2m is going to be a negative 6m. And negative 3 times negative 3 is a positive 9. And again, we just now need to go through and combine those like terms by adding. And our final answer here would be just 4m squared plus negative 12m plus 9. So special case polynomials here. Let's go ahead and look at our last slide. Again, we have some more special cases. Problem that x plus 8, for example 1, and squared means times itself. Write it out that way. These are special cases, but our process is the exact same. That's it. What you notice about these two different binomials in example 3 and example 4, I have x plus 9 and then x minus 9. If you look at the bottom one, everything's the same except you have 3c minus 4 and 3c plus 4. So the binomials look the same except one's plus, one's minus in the middle. You're going to see what happens when we multiply here. Again, you know I would change it to add a negative. So here we go. X times x is x squared. X times negative 9 is a negative 9x. So I multiplied my x by everything. Now we need to multiply the 9 by every term in the other set of parentheses. So 9 times x, 9x. And 9 times negative 9 is a negative 81. So we do have like terms here in the middle, but what do you notice about those like terms? They're opposites. Negative 9x and positive 9x get you nothing. So this is just x squared plus negative 81. What's your final answer? That would be 0 in the middle. We don't need to write 0. You're going to notice probably in my next example, not probably, you will notice it, I hope, that my like terms are going to cancel out just like they did up above. That's what happens when we just kind of have, or when we have the opposite polynomials here, or binomials, opposite terms. Let's go ahead and change this to plus and negative. So 3c times 3c is going to be 9c squared. 3c times positive 4 is going to be a positive 12c. Let's multiply my negative 4 by everything. Negative 4 times positive 3c is a negative 12c. And a negative 4 and a positive 4 is a negative 16. And again, because we have the 3c minus 4 and then the 3c plus 4, the only thing different in those binomials is the plus and minus. It's going to cancel out our like terms here. 12c and negative 12c is nothing. So our final answer here is just 9c squared plus negative 16. And I hope what you notice is maybe our answers look a little different than what we've had in the past, or the way